So at this time, we're still working on finding some exact values, but we'll change the script up a little bit. What we were doing is we were given the angle and we were breaking it up into a sum or a difference. Now what we're trying to do is find the exact value of a sum or difference given other information. So in this case, we know that theta is in quad number 2, beta is in quad number 4. We're told that the sine of theta is 4 over 5, and we're told that the cosine of beta is 1/3. And so use all that information to find the exact value of the sine of theta plus beta. So by definition, this is basically the sine of theta, the cosine of beta, plus the cosine of theta, the sine of beta. All right, so that's invoking our trig identity of a sum. And then, of course, with the information we have, we know that the sine of theta is 4/5, but we don't know the cosine of beta yet. Or actually, we do. It's 1/3. So that's the good news, but we don't know these two guys. So there is where our problem's at. So as soon as I can find these two, then I can pretty much put this together, and that's a 1/3. Sorry, we know what the cosine of beta and sine of beta. So how do we find those? Well, again, we can use x, y, r definitions to help us. We can use right triangles to help us, or we can use trig identities to help us. All right, and so you'll see me doing a little bit of both, or all three. Just it's a good review, especially for a final coming up, and all that other good stuff. So how about why don't we work with the sine of theta first? And what I'll do here is I'll use trig identities. So we know that the cosine of squared theta plus the sine squared theta is equal to 1. So this is cosine squared theta plus 4 over 5 squared is equal to 1. So we're basically looking at the cosine squared theta equals 1 minus 16 over 25. This is 25 over 25. So we get the cosine squared theta, that's 9 over 25. Taking a square root, cosine of theta becomes plus or minus 3 over 5. And since we're in quad number 2, we know that the cosine of theta is negative. Alright, so there's our cosine of theta. So we can come back up here and start filling in some of the blanks. Alright, so this is negative 3 over 5. Right, so what about the sine of beta? Well, we could use the trig identity again, right? But since I've used the trig identity, how about we just use a right triangle? So using a right triangle, where cosine of beta is in quad number 4. So here's x and here's y. So in quad number 4, I have an angle, x and r. So what we have is x is 1 and r is 3. So we're looking at 3 and 1, and we got to find out what y is. So x squared plus y squared is r squared, and so we have 1 squared plus y squared is 3 squared. This is y squared equals to 8. Taking a square root, we get y is plus or minus the square root of 8. Two things here, we're in quadrant number 4, so we can see y is going to be negative, and then 8 breaks down into 4 times 2, which gives us negative 2 square roots of 2. So the sine of beta then is this y value over this r value. And so there's our sine. So we got negative 2 square roots of 2 all over 3. And so now we just put this together. So we got 4 over 15, and it looks like we have positive, because that was a negative and that was a negative, 6 square roots of 2 all over 15. And so possibly putting this all together, right, this would be 4 plus 6 square roots of 2 all over 15. So there would be, let me write it up here, so 4 plus 6 square roots of 2 all over 15. So for the theta and beta that are given, that's basically what sine of theta plus beta would be given that situation. All right, so hopefully some good review and just kind of piecing the story together, if you would. I think I have time to do the next one, and then we'll use another video to do the bottom. So in the next one, again, very similar, theta's in quad number 3 and beta's in quad number 2, and we're told that the tangent of theta is a half and the sine of beta is 1/4. So they're asking us to find the value of the tangent of theta minus beta. So we'll begin by invoking the trig identity. So that's the tangent of theta minus the tangent of beta all over 1 minus the tangent of theta tangent of beta. Alright, and so the good news is we already know what the tangent of theta is. So most of our work in terms of that's done, but we don't know the tangent of beta, so we got to find that. So how do we do that? Well, I've used the trig identity, and I've used a right triangle, so how about I use XYRs? So beta's in quad 2, so that would mean that there's my y value and there's my r value, and we're expecting our x to be negative because we're in quad 2. So putting this all together, x squared plus y squared is equal to r squared. So we have x squared plus 1 is equal to 16. So x squared is equal to 15. Taking a square root and invoking these negative, we have negative square roots of 15. So we know that the tangent is y over x. So in this case, it'd be 1 over negative square root of 15. And if we rationalize that denominator, we'd get that this is negative square root of 15 over 15. So there's our tangent of beta. So now we get to go plug all this in. So tangent of theta, well, it was given as 1/2. All right, and then we're going to subtract the tangent of beta, which I just found to be negative square root of 15 over 15, and then divide that by 1 plus 1/2 times negative square root of 15 over 15. So there we have it, and we got this really big complicated fraction. So this becomes 1/2 plus the square root of 15 over 15, and the bottom becomes 1 plus, actually minus, because negative times a positive is a negative, square root of 15 over 30. And we still have some simplification to do under this, guys. So using the same trick upstairs and downstairs, the common denominator is 30. So I'll multiply both upstairs and downstairs by 30 and distribute. So we end up with 15 plus 2 square roots of 15. And down on the bottom we end up with 30 minus the square root of 15. Okay, so good news, bad news is we're kind of reduced it, but we still have a radical down on the bottom. So let me give myself some more paper here. We got to rationalize that denominator. So right now we have 15 plus 2 square roots of 15 all over 30 minus the square root of 15. So we need a conjugate. And upstairs, 30 times 15, let's see, that's going to be 450, right? Because 3 times 15 is 45 and a 0. So that's that. And then we got plus 15 square root of 15. And then here we got plus 60 square root of 15. And then back here we basically have 2 times 15. All over we have 900 minus 15, right? Because we got the difference of squares. 30 times 30 is 900, and then the square root of 15 times the square root of 15 is 15. All right, I think that's 30, and 450, that's 480. And then 15 plus 60, that's 75 square roots of 15. And on the bottom, we basically have, what is that going to be? 885. So that's a lot of fun. All right, I think I can clearly see. I'm going to go ahead and break out my. Where's my calculator at? All right, so let's go ahead and break out. I think 5 goes into everybody. As a matter of fact, we might even do better. How about we kind of play around with this? So let's take 480 and divide it by 15. Yeah, so that's 32. I know 75 divided by 15 is 5. And I'm hoping 885 divided by 15 is a nice number. It is. It's 59. And so there you go. All right, so that was crazy. So this value, putting it all together, right, comes out to be 32 plus 5 square root of 15 all over 39. Okay, so I think the tough thing about this is all the stuff we learned in college algebra or way back in intermediate algebra. The trig's actually the easy part, right? It's the simplification of all these fractions where it gets a little hairy. But hopefully, again, I've kind of made you guys work with fractions. Hopefully there's going to be some sort of a payoff. But that is how we find some exact values. I'm going to go ahead. We're almost 11 minutes into this. We'll do the bottom half in another video coming soon.